Have you ever wondered what a sunset looks like on the moon? No atmosphere, no vibrant colors, just a breathtaking interplay of light and shadow in a completely alien landscape. But how did NASA manage to capture this moment in high definition? Today, we're diving into the cutting-edge technology behind this achievement, the challenges of photographing in space, and what this means for the future of astrophotography. Get ready to explore the fascinating world of space imaging, because what you're about to see might change the way you look at the universe forever. But before we reveal how this was done, let's first understand why capturing a lunar sunset is so unique. On Earth, sunsets paint the sky with brilliant shades of red, orange, and pink. That's because our atmosphere scatters sunlight, filtering out different wavelengths as the sun dips below the horizon. But on the moon, things are entirely different. With no atmosphere to diffuse light, there's no gradual transition from day to night. The sun doesn't fade into warm hues. It simply vanishes behind the lunar horizon, leaving a stark contrast between blinding daylight and absolute darkness. This extreme lighting makes photographing a lunar sunset incredibly challenging. Without atmospheric effects to soften the scene, shadows become razor-sharp, and brightness differences can overwhelm even the most advanced cameras. But NASA had a plan. To capture this event in high definition, they needed a specialized camera, precise timing, and innovative image processing techniques. Let's take a closer look at the technology that made it possible. Capturing a high-definition sunset on the moon required more than just pointing a camera at the horizon. Without an atmosphere to soften light transitions, the stark contrast between intense sunlight and deep shadow posed a serious challenge. So, how did NASA do it? First, they used a specialized imaging system designed for extreme conditions. Equipped with high dynamic range HDR sensors, this camera could handle the moon's harsh lighting, preserving details in both the brightest and darkest areas. Second, precision timing was crucial. Since lunar days last about 29.5 Earth days, the transition from light to darkness is much slower than on Earth. NASA's engineers had to calculate the exact moment to capture the most striking images, ensuring the best balance of illumination and shadow. Finally, advanced image processing played a key role. Even with cutting-edge hardware, raw space images often need refinement. Scientists used sophisticated algorithms to enhance contrast, correct exposure imbalances, and bring out hidden details in the lunar landscape. But technology alone wasn't enough. The moon's unique environment introduced challenges that even the best equipment had to overcome. Let's explore the obstacles NASA faced in capturing this unprecedented moment. Photographing a lunar sunset wasn't just about having the right camera. It was about overcoming the extreme conditions of space. Without an atmosphere, light behaves differently, and even the most advanced imaging systems face serious challenges. On the moon, there's no gradual twilight. The sun goes from blindingly bright to complete darkness almost instantly. Capturing a balanced image required precise exposure settings to avoid overexposing the highlights or losing details in the shadows. On Earth, the atmosphere scatters light, creating soft transitions between day and night. Without this effect, the contrast on the moon is extreme, making it difficult to capture depth and detail in images. Even though the moon's gravity is weaker than Earth's, any movement, whether from vibrations, temperature shifts, or mechanical adjustments, could introduce blurring. NASA had to ensure the camera remained perfectly stable throughout the capture process. Capturing a high-resolution image is one thing. Sending it back to Earth is another. NASA relied on advanced communication networks to transmit these massive files without losing quality, ensuring every detail of the lunar sunset was preserved. Despite these obstacles, NASA's team managed to achieve something extraordinary. But why does this matter? What does this breakthrough mean for the future of space exploration and photography? Let's take a look. NASA's successful capture of a high-definition lunar sunset isn't just a technological achievement, it's a glimpse into the future of space imaging. This breakthrough opens doors for more advanced photographic techniques that could revolutionize the way we explore and document the cosmos. With improved imaging systems, future missions could capture sunsets on Mars, the shifting atmospheres of gas giants, or even the glowing horizons of distant exoplanets. These advancements will be crucial for understanding planetary environments, identifying habitable worlds, and even planning future human settlements beyond Earth. For astrophotographers and engineers, this milestone serves as an inspiration. The same principles used in lunar imaging can be applied to deep space photography, helping scientists refine techniques for capturing distant celestial bodies with greater clarity than ever before. As space agencies and private companies push the boundaries of exploration, one thing is clear: the way we see the universe is changing. And with every new image, we get one step closer to unlocking its deepest secrets. But before we wrap up, let's take a final look at the breathtaking images of the first high-definition lunar sunset and reflect on what this achievement means for the future of exploration. As we look at the first high-definition images of a lunar sunset, it's impossible not to wonder, what's next? Every breakthrough in space photography brings us closer to capturing the universe in ways we never imagined. From the Moon to Mars, from distant exoplanets to the edge of the observable cosmos, the technology behind these images is shaping the future of exploration. But this isn't just about NASA or space agencies, it's about all of us. The same passion that drives scientists to capture the perfect shot of a lunar sunset is the same passion that fuels photographers, engineers, and dreamers around the world. So now, we turn the question to you. If you could capture any celestial event in high definition, what would it be? A Martian sunrise? A supernova explosion? The rings of Saturn up close? Let us know in the comments. And if you enjoyed this deep dive into the technology and challenges behind space photography, don't forget to like, share, and subscribe. There's a whole universe out there waiting to be explored, and together we'll uncover its greatest secrets, one image at a time. See you in the next journey through the cosmos.